To prove or verify this identity, to me, both sides look equally complicated. I don't jump out ahead at one versus the other. I'm going to start with the right-hand side. So I have cotangent theta over cosecant theta plus 1. Now, what I want to do, this is an interesting technique, and it shows up a lot in identities the more you do them. You want to multiply by 1 in a special form. This is such a powerful technique in mathematics, either multiplying by 1 or adding or subtracting 0 and they're always in a special form, because you know that you're not changing the value of the thing you're working with, you're just changing the way it looks. So I'm going to multiply this whole thing by 1 in the special form of the conjugate of the denominator. So I'm going to multiply it by cosecant theta minus 1 under or over cosecant theta minus 1. And what that does is it's going to turn our denominator into, when we multiply it out, it's going to be the difference of two squares. So we get cotangent theta times cosecant theta minus 1. And when I multiply the denominator, I get cosecant squared theta minus 1. Now you might wonder why there's an advantage to this, but if you remember one of the versions of the Pythagorean identity, we know that cosecant theta squared theta minus 1 is cotangent squared theta. So if I write this as cotangent theta cosecant theta minus 1 over cotangent squared theta, then I know that this is one factor and the stuff in the parentheses is another factor in the numerator. I can cancel one of these cotangents with one of those, and I end up with cosecant theta minus 1 over cotangent theta, which is the left-hand side and what we set out to show. One of the things that inspired me to do this step is noticing that there's the conjugate up here on the side we're trying to get to. We have cosecant theta plus 1 down here. The conjugate is up here. So if I multiply this fraction by 1 in a special form of the conjugate over the conjugate, then that's going to give me the conjugate I need up here in the numerator. And I know that I need that. You could have done the same thing with this side. You could have multiplied it by 1 in the special form of cosecant theta plus 1 over cosecant theta plus 1. And that's the conjugate of this, which puts the conjugate that you're looking for in the denominator here. If you started with the left side and you were working towards the right, and then you would have to work with the Pythagorean identity again. Try it. Start from the left-hand side, use this conjugate, and work your way through and prove it that it gets to the right side. It's good practice, and put this idea of multiplying by 1 in a special form using the conjugate, put that into your toolbox, because it's an idea that's going to come back up again and again that you can use to help you out.